So the cells of the bone you already know a little bit about, but let's cover them a little more in depth. Cells of the bone really are only about 2% of the whole entire bone mass as compared to the inorganic portion, which is the calcium salts. They make up about 2/3 of bone. And then there's the organic part, of which 2% is these cells, and the rest of that 1/3 that's left after you consider the calcium are the collagen fibers. Right? So we've got the 2% of mass that we're talking about, but nonetheless, of course, incredibly important. There are 4 types of cells here. The first one we're going to talk about are the osteoprogenitor cells, or just simply the osteogenic cells. These are your stem cells of bones, the ones from which additional bone cells like osteoblast can be manufactured. They're found in a layer of bone tissue called the endosteum. They'll also be found in the inner layer of the periosteum. We'll be talking about those in a video or two. In addition, these osteogenic cells are really important in repair. Osteoblasts are the cells that manufacture the bone matrix, right? So they're involved with the process called osteogenesis, or the formation of bone. Once they become surrounded by bone matrix, then osteoblasts become osteocytes. And osteocytes are, of course, the mature bone cell. We're going to see them residing just like chondrocytes do in lacunae. So these are pits, remember, that the cells are inside of because they've been oozing and secreting matrix, and they stop, and they'll stop before they're completely encased. So there's always a little bit of space between the cell and the surrounding matrix. So these are the lacunae. And now we're going to introduce a whole brand new term called lamellae. Lamellae are the layers of the matrix that are produced by the osteoblast. Once the osteocytes become formed after the osteoblasts are done with their job, then we'll find them in these layers called lamellae. Connecting osteocytes together are small channels called canaliculi that we addressed last video. This allows cytoplasmic extensions from the osteocytes to extend through them and make contact with neighboring osteocytes. Thus, they can share information about what's going on in the bone, and exchange materials if necessary, and to help repair the bone. Finally, we hit osteoclast. These are the cells that break down bone tissue. They're quite a bit different than the others that we've been talking about, and they have a different history to them of how they develop. But when they end up as osteoclasts, they have about 50 or so nuclei inside them because they produce a tremendous number of proteins and enzymes necessary to break down bone. So these enzymes are going to be degrading enzymes, and they're going to help break down the bone. All right, so let's take a look at an osteocyte in a lacuna. I think it's just a beautiful shot. You can see some of the cellular processes extending out from the cell into the surrounding matrix as they cross the lacunae cavity there. I just love this shot. So that is an osteocyte in the middle of that black space, and then those are cytoplasmic extensions where they go to other osteocytes in the bone. So how do osteocytes develop? This is a great shot here. We start with some type of osteogenic cell. It gets a signal. Hey, we're going to need more osteoblasts. The osteoblasts are formed, rich in organelles, as they begin to secrete and manufacture and secrete the matrix around them. Then we get the formation of the osteocyte. And this is just the histology. You can see the different cell shapes involved here. The osteoblast has a much greater definition to it as it's developed a lot more density of organelles. Then the osteocyte changes form completely, sheds a lot of the cytoplasm, forms the cytoplasmic processes that will proceed through the canaliculi. And then completely separate from these three on the left is the osteoclast. And you can see pictures of those, the blast, the site, and the clast below you. Just great stuff, great stuff. Bone tissue. How do we maintain homeostasis of bone tissue? Well, our last video is going to be all about that, and it's through hormonal control. But homeostasis of bone tissue is accomplished through the two cell types of the osteoblast and osteoclast. And it's all about how one is building up the bone and one is breaking it down. And you want those to be pretty much even. And if one begins to dominate over the other, you're going to have some issues